Hello, my name is Heidi Schutz, and I will be presenting my research proposal on habitual intake of caffeine on resistance-trained females. Caffeine is dubbed as one of the most utilized ergogenic or physical performance-enhancing supplements. It is found in various naturally derived common food items such as coffee, tea, and carbonated beverages, and has been extensively investigated in the literature. 90% of U.S. adults consume it on a daily basis, with an average of adults consuming 200 milligrams of caffeine per day. It is a popular substance among individuals due to its stimulant properties on the central nervous system, which can enhance one's alertness, attention, and cognitive performance. These ergogenic effects have been described among numerous researchers, demonstrating the positive role caffeine may play in athletic performance. Various sectors of the fitness community use caffeine as an ergogenic aid in training and athletic competitions, ranging from mixed martial arts to group sports, cycling, sprinting, and modalities of resistance training. Research has focused on various levels of caffeine ingestion to determine optimal doses for different fitness practitioners. With the rise of fitness trends such as wearable technology, group training exercises such as CrossFit and boxing, and streaming workouts, resistance training has steadily increased over the years, with women acknowledging the benefits that resistance training may provide. It is well established that low to moderate doses of caffeine have an ergogenic effect on endurance performance. The research to support the effect of caffeine on resistance training is less consistent. Previous studies that have examined caffeine intake and resistance training have vastly differed in their control of variables, and the fact that researchers have not tightly controlled for variables may lead to these possible inconsistent results. Finally, most studies to date have focused on the male population only, while very few studies have actually studied the acute effects of caffeine ingestion on muscular endurance. Thus, my research question is going to aim to seek: does habitual caffeine intake lead to an increase in muscular endurance in resistance-trained females aged 25 to 35? As widely studied as caffeine is, majority of the research has focused on the male population, with current research identifying women comprising only 13.2% of the total samples. As gender has also been identified as an important determinant of athletic performance by way of body composition, aerobic and anaerobic capacity thresholds, recommendations for each gender should be tailored uniquely to allow for the best possible results in sports performance. Therefore, my study proposal will focus on two important factors, one of which will be the habitual caffeine intake, as more studies have shown habitual caffeine intake to help increase certain facets of athletic performance. And secondly, the emphasis on muscular endurance. Of the different fitness facets that have been studied, muscular endurance has had some equivocal findings amongst the research community. A review of the literature does show overall positive effects on exercise performance. Several facets underneath the aerobic category have been shown to be positive. Examples of the aerobic performance include short, high-intensity interval training, swimming, and cycling. In comparison, anaerobic training has also shown to have positive effects within its exercise performance. And examples of these include weightlifting, vertical jump height, sprinting, and resistance training. Furthermore, dosages have been studied at various levels. The consensus amongst the literature does show that low to moderate doses, roughly around the 3 to 6 milligram per kilogram per person, to be the most ergogenic or the most sports enhancing. This is equivalent to approximately 2 to 4 cups of coffee. The habitual versus acute users, when it comes to caffeine consumption, have been conflicting. The culmination of scientific data has studied caffeine supplementation on the male population, and the few studies that are available on women are outdated, and yet moderate dosages had led to increased aerobic performance in non-habituated users and increases in muscular and strength endurance in resistance-trained females. A systemic review evaluated differences between genders with caffeine supplementation, highlighting the difference between muscle power and speed among genders to be a major finding. A more recent finding by Fett et al. Found caffeine improved tolerance to exhaustion and improved strength in young women. The first study ever to investigate caffeine supplementation in resistance-trained women was conducted by Goldstein et al., who demonstrated that 6 milligrams of kilogram per dose of caffeine was effective for enhancing strength, but not muscular endurance in resistance-trained women. My study will seek to replicate the study of Goldstein et al. And add to the body of knowledge that caffeine, in fact, can be effective for improving muscular endurance, as demonstrated by other literature. Synthesis of the literature reveals that caffeine is understudied in the female population, while showing that few studies examining caffeine ingestion with resistance-trained females seem to improve muscular. Methodology will consist of a quantitative design using an experimental, double-blind, randomized, placebo-controlled crossover design, where each participant will serve as her own control. Research participants will be asked to attend 3 laboratory sessions, the first session for familiarization, followed by 2 testing trials 7 days apart using the same testing protocol. All testing will be taking place between 9 and 11 a.m. to avoid circadian variation. Either caffeine at a dose of 6 milligrams per kilogram or placebo will be administered orally 60 minutes prior to testing in randomized order. The supplementation protocol will consist of 2 exercise trials, one with habituated and the second without caffeine users. The testing protocol itself would consist of max push-ups following the 2 trial sessions after the familiarization session, all to assess for muscular endurance. The supplement will consist of 6 milligrams per kilogram of caffeine in powder form, added and mixed into a 16.9 ounce of Flavor Propel Fitness water, where the placebo will be just a Propel Fitness water. In terms of the data collection, habitual caffeine intake will be used from an adapted food frequency questionnaire in a previous study used by Wilk et al. Also, a health history questionnaire will be conducted to get a general overview of the participants' health. They will be tracking their food intake through a dietary log through the online chronometer. A push-up counter will be used, overseen by a nutritionist at the gym. Of course, informed consent with special attention will be focused. Informed consent will make sure to be describe all procedures of the testing prior to the start of testing, describe in detail what each procedure will entail, and also any risk to benefits, any data collection and storage, contact information, and a consent statement will be all described in the informed consent. And prior to any data collection, IRB approval will be sought. For recruitment, posters, flyers, emails, and sign-up sheets at local gyms, recreational facilities, CrossFit gyms, and local coffee and vitamin supplement shops will be all used. The goal is to use 30 participants as reflected in a previous study in the literature. This is an example of the Adapted Food Frequency Questionnaire taken from the Wilk et al. Study that will be distributed to participants prior to the start of testing. The analysis I will use will be statistical and will consist of a one-way ANOVA. The outcome measures will be statistically examined to determine if there were significant differences between conditions, the caffeine and the placebo, through the one-way ANOVA with repeated measures. The statistical significance will be set at less than 0.05. The data will also be assessed for normality with normal data using mean and standard deviation, and non-normal data being described by the median and interquartile range. I will also use descriptive statistics to describe the study population. Strengths of the study include contribution to literature in underrepresented population, elucidation of gender differences in dosing. Conversely, limitations include variability in caffeine habituation, different confounding variables such as genetic factors, including polymorphisms that may contribute to how caffeine is metabolized in an individual, and also the menstrual cycle. Inaccurate dietary logging may also be problematic. Future research can consider a couple different things. Athletes, coaches, and practitioners looking to use caffeine as a means to enhance performance would be best placed to experiment with various different caffeine doses to determine the optimal dose to enhance their performance given their own unique biology, history, and performance requirements. It is of great importance to continue the work in future research on supplementation with caffeine in female populations. Specifically, it is necessary to determine whether women athletes benefit from acute caffeine intake versus chronic intake in other forms of exercise or in sports, where various physical fitness variables affect overall performance. And lastly, the menstrual cycle needs to be considered. Menstrual cycle can have different effects that are more unknown on how a woman may perform physically, and that is something that could be addressed in the future. Thank you so much.